Hello all, welcome to Unacademy. Wishing you a very happy new year. Today we will going to see our first lecture on discrete mathematics, which is very important for the second IT and Com. Those who are appearing from IT and Com branch, that is very useful. So we will discuss here each and every concept of discrete mathematics, that is from sets. I know that it is already done in your previous standards, but still we will take a review on it, and then we will move further for the next topic also in that discrete mathematics. Okay, so before going to start this, let me introduce myself Dhanashree Mam. I completed my MSc in mathematics from Mumbai University, and I also having 13 plus years of teaching experience, and I mentored more than 10,000 plus students for the engineering. Now, I will tell you just one review how to install the Unacademy's learning app. First, go to your mobile's learning app, then go to your mobile's Play Store app and then search Unacademy's learning app. After that, you will install that app and then you will manage your goal here. जैसे कि हम लोग यहाँ पे अभी GATE and ESE के लिए पढ़ रहे हैं, so you can manage your goal whatever you want, in which goal you want to study, that goal you will manage over here. जैसे कि मैंने अभी यहाँ पे GATE and ESE के लिए manage किया हुआ है. Then you can take any subscription plan, either for free subscription, free classes, plus classes, free special classes. You can choose any one of that and press the get subscription button. And the most important thing I'm going to tell you, if you wanna going to prepare for the GATE 2022, then I will suggest you can go for the plan 24 months plan, so that your each and every concept will be clear in that. So and then next also, here you can choose your plan accordingly as per your requirement. And the most important thing I'm going to tell you here, you can use my promo code DSP to get the 10% discount on your subscription fees. And last thing, you can pay your subscription fees by using any one of these methods, either by credit card, debit card, UPI, EMI, anything you can choose here. Now next, to unlock the free plan of Unacademy, you can use my promo code DSP for the special class, for the live test series, for quiz and Unacademy Combat. Now, next, in this lecture we will study sets, definition of a set, methods of describing sets, subsets, proper subsets, empty sets and forward set. Okay, each and everything we will study with example. So first of all, what do you mean by set? I will tell you. There is sets, definition of a set. Set is a well-defined collection of objects. Set is a collection of well-defined object, right? For example, we can see that your set of natural number is a collection of well-defined object and so on. Set of whole numbers, it is again a collection of well-defined objects. Okay. Or set of vowels in an English alphabet, that is also a well-defined collection of objects. Suppose you can write here set of vowels A, E, I, O, U. This is also a set which is well defined. It means collection of all the vowels from the English alphabet. So this is your collection of a well defined objects. Okay. Next we will see the definition of it's done. Then methods of describing sets. Okay, there are two methods actually. Two methods we can see here. Methods to describe the set. Are that first is roster method, or also it is called as listing method. Roster method or listing method. Roster method or listing method. You can see it in this a set, in this method, we will describe all the elements of a set by separated by comma. Okay? So in this method, we will describe. तब यहाँ पे हम लोग जो भी elements है sets के वो describe करेंगे by separated of comma. Okay, suppose this is your set and each element of this set is separated by comma. This is roster method or listing method. It means every element of that set you can describe here. Okay. Now, again the next method is set selector method or set builder form method. Okay. Set selector method or set builder form method. Set selected method or set builder form method. In this method we can see, so instead of writing all the elements separated by comma, only we will write it here. Suppose for example, if we take here b is equal to the set, here x is less than or equal to 4. Okay, or x is less than or equal to 4. So all the elements x such that x is less than or equal to 4, where x belongs to natural number. Okay, so this is set builder form. Instead of writing all the elements which are less than 4 and belongs to natural number, instead of writing that, we will separate this elements of this set by using comma. We can write directly here x such that x is less than or equal to 4, x belongs to n. मतलब यहाँ पे समझ में आ रहा है कि इस सेट में सारे elements है जो less than or equal to 4 है और वो सारे elements natural numbers है. Right, so each and every element belongs to this sets which is natural number and also less than or equal to 4. Right, so this is set builder form method. So this method is very convenient to denote the set number of elements present in that set, which is actually here it is very simplest way to denote the set. Suppose for example, if I want to write the set of all odd numbers between x such that x is a odd number, one less than or equal to x less than or equal to 100. Okay, and where x belongs to natural number. Okay, this is very simplest way to write that set. Instead of writing separated by comma, this is very simplest way. यहाँ पे हमने ये देख के समझ में आ रहा है कि इस set में सारे odd numbers है between 1 to 100. Instead of writing the elements 1, 3, 5, 7 and so on, we can write in this way. Okay. Now next we will see the definition of a subset. Okay. Subset. What do you mean by subset? A is said to be subset of B. A is said to be subset of B if every element of A, if every element of A is an element of B, is an element of B, right? Then we say that A is a subset of B. A में से हर एक element B में होना चाहिए, तभी हम लोग बोल सकते हैं कि A is a subset of B, right? So यहाँ पे देखो, अगर for example we will see here A is equal to, suppose can say, can write here A is subset of B. It means A is equal to suppose 1 to 3 and B is equal to 1 to 10. 1, 2, 3 up to 10. So obviously A is a subset of B because every element of A is an element of B. Okay, therefore A is a subset of B. Now next is, we can say that proper subset. What do you mean by proper subset? What do you mean by proper subset? Proper subset, it means the set A is said to be proper subset of B. The number of elements A and B are not same. Okay, number of elements, proper subset. The number of elements A is said to be proper subset of B if A is not equal to B. A is a subset of B. Now the proper subset is denoted by this. A is the proper subset of B when if A is a subset of B and A is not equal to B. For example, set of natural number is a proper set of whole numbers because the both sets are not equal. Only 0 is added in that whole number so that n becomes a proper subset of whole numbers. Okay. So it means n is not equal to w and n is a subset of w. Right. So n is called as proper subset of w, set of whole numbers. Okay. Now next moving forward, here we will see operation power set. Also one thing is remaining, power set. What do you mean by power set? Power set of A. Power set of A. It means set of all subsets of A. Set of all subsets of A is called power set of A. Right? Set of all subsets of A is called power set of A. For example, we can see here A is a suppose A is equal to 1, 2, 3. Right? Then and power set of A is denoted by here P of A. Now this is your set A, so P of A. So P of A is equal to here first subset is empty set. Empty set is a subset of every set. So empty set singleton 1, singleton 2, singleton 3, singleton 1, 2, singleton 1, 3, singleton 2, 3, right? And singleton 1, 2, 3. These are the power set of A. And power set of A is 2 raised to n. The number of elements in a power set of A is 2 raised to n. You can check it here. N is equal to 3. 2 raised to 3 is 8. So you will get power set of A is 1, 2, 2 raised to 3 is 8, 1, 2, 3, 4, 5, 6, 7, 8. Right? So total number of elements containing in the power set of A is 2 raised to n. Okay? Now next we'll move forward. Next is operations on sets. Okay. We denote all the operations by using Venn diagrams. Okay. We will study all these operations by using Venn diagrams. So here we can write of union of sets. So what do you mean by union of sets here? Union of sets. Right? Here union of sets. Here union of sets. First, let A and B be sets of universal set U. Anything? Let A and B. So union of let A and B is subsets of universal set U. Sets of universal set U. Then A union B is equal to the element X belongs to A union B, means the elements X such that X belongs to A or X belongs to okay. X belongs to A union B. It means the element either X belongs to A or X belongs to B. We can denote it by the Venn diagram. See here. Suppose this is your set A. This is your set B. Right? This is your set A, set B. then we can denote the union of these two elements by shaded portion. All the elements containing both the sets, right? This is represented by Venn diagram. Venn diagram, it means a picture-wise description of a pictures in a mathematics studies. The relation between the sets can be conveniently illustrated by certain diagrams. Okay, it's denoted by Venn diagrams. Now here, this is your total A union B. Okay, so shaded portion denoted A union B. Yeah. So we define the A union B here. A union B is equal to this. Now next. Now we denote intersection. If you want, you can take any examples here. For example, A is equal to suppose 1, 2, 3. B is equal to 6, 7, 8, 9, 10. And U is equal to 1 to 10. Okay. So you will get A union B is equal to the elements which are in A as well as, and every element appears exactly once, right? So A union B contains this. Now second one, intersection of two sets. Okay. Intersection of two sets. So what do you mean by A intersection B here? So A intersection B can denoted by here A intersection B is equal to, here A is equal to, you will get suppose, and write A intersection B is equal to X such that X is in A and, this word is important, X is in A and X is in B. It is come to the both the sets. X is in A as well as in B. So A intersection B is equal to, you can denote by Venn diagram. Suppose this is your A, this is your B. So A, B, we can denote the intersection of these two elements. Here we can denote the intersection of these two elements is A by shaded portion. So the elements which are common to both. Here A intersection B, okay, denoted by this. So A intersection B, right? So you will get the intersection of two elements which are common to both. That is your A intersection B. Okay. Now next is, we will denote here, for can take one example. First, suppose A is equal to, here A is U, first we write U universal set 1 to 10, and A contains suppose 2, 3, 4, 5, 7, and B contains 1, 2, 3, 4, 8, 9, right? So what are the elements in A intersection B? The elements which are common to both. So which elements are common in both the sets? So here is 3, 3, 4, 4. Okay, so 3 and 4. The elements A intersection B contains only 3 and 4. Okay. Now the third step, that is disjoint sets. Okay. We can write here disjoint set. So what do you mean by disjoint sets here? So A and B are set called disjoint sets if there is no common element, right? A and B are said to be disjoint, if there is no common element. There is no common element in both sets, right? No common element in both sets. So we can denote it by Venn diagram. So we can denote this by using Venn diagram here. Suppose this is your set A and this is your set B. So these two sets are disjoint, A and B, denoted by this. Okay. Now next is difference of two sets, right? Fourth one, that is difference of two sets. Difference of sets. So we can denote A difference B is equal to x such that x is in A and x is not in B. Then we denote this difference as A difference B. So x is in A and x is not in B, right? So we will get here A difference B. And how we denote this? By using Venn diagram. The elements which are in A but not in B. Suppose this is your set A and this is your set B, right? A and B. So A difference B, how we can denote? Can denote here A difference B, the elements which are in A but not in B. Yeah, this is your A difference B. Shaded portion denotes A difference B, right? So the elements which are in A but not in B. Now, if we can take any element here, and similarly B minus A, it means the elements which are in B but not in A. Okay. Now suppose we can take one example here. A is equal to suppose 1, 2, 3, 4, and we can take B is equal to suppose 4, 5, 6, 7, right? So we can denote A difference B. A difference B, it means the elements which are in A but not in B. So which are that elements? Elements which are in A but not in B? Yes, 1, 2, 3, not in B, correct? So this is your A difference B. So what is B difference A here? The elements which are in B but not in A, that is 5, 6, 7. You getting it? So how to denote the different elements or difference of any two sets, A difference B and B difference A, by using Venn diagram also and with the help of example also. Okay. Now the next point we will see symmetric difference of two sets. Symmetric difference of two sets. Right? Symmetric difference of two sets. Let A and B be two sets. Then symmetric difference of two sets is denoted by either A triangle B. This is symmetric difference, or A ring sum B. Generally we will use A ring sum B. So how we defined A ring sum B? A ring sum B is same as A minus B union B minus A. Okay. So symmetric difference of two sets can be denoted by A difference B is equal to A minus B union B minus A. Okay, the elements which are in A but not in B union the elements which are in B but not in A. Now how we denote? By using Venn diagram. Okay. Now we'll take the union of this asymmetric difference B. So here suppose your set A, this is your set B. Then A difference B, A minus B. It means the elements which are in A but not in B. So how we denote? The elements which are in A but not in B, and the union elements which are in B but not in A. Now as I told you here, see the elements which are in A but not in B, A difference B, can denote by this way. Okay. We'll shaded this portion, the elements which are in A but not in B, right? Shaded portion is denoted by A difference B, A minus B, and the elements which are in B but not in A, this only, and union of these two denoted by this shaded portion, right? So this is your B minus A. So union of these two is denoted by A difference B, right? So the shaded portion is denoted by A difference B. Yeah. So union of these two, A minus B union B minus A. Now next, we can take any set, any element, and suppose A is equal to 1, 2, 3, 4, B is equal to 4, 5, 6, 7, 8, right? So how we can write A difference B? A difference B is the elements which are in A but not in B. Only 1, 2, 3, right? B difference A. It means the elements which are in B but not in A. So it is only 5, 6, 7, 8. And we take the union of these two. So union of these two is A symmetric difference B can be denoted by A ring sum B is equal to union of these two 1, 2, 3, 5, 6, 7, 8. Right? So union of these two sets denoted the symmetric difference of A and B. Okay. Now the next point is complement of a set. So complement of a set, it means what? Complement of a set. Okay. So a complement is generally denoted by x minus a, where x is your universal set. Or either we can write a complement is equal to x such that x belongs to x and x does not belongs to a. Right? X belongs to x and x does not belong to a. So how we can denote it by the using Venn diagram. Now see here complement we can denote. Suppose this is your set X, the elements which are in A. So here a complement, suppose this is your set A. So what will be your complement of A? The remaining portion. Right? This is the complement of A. Are you getting it? This, the shaded portion is denoted by complement of A. Complement of A by A complement. Yeah, the elements which are in X but not in A is contained in complement of A. Now, the next is algebra of set operations. So we denote the algebra of set operations. Now see, there are many laws here. First, let A, B, C be any subsets of, and write, let A, B, C be any subsets of X. Any subsets of X. Then we denote the idempotent law. So idempotent law for the union. So A union A is equal to A, idempotent law, right? Second, A intersection A is equal to A is again an idempotent law. Now commutative law. So commutative law for the union, A union B is equal to B union A. This is commutative law. Now second, here A intersection B is equal to B intersection A. This is your again commutative law for the intersection and union. Now associative law. So we can write associative first. A union B union C is same as A union B union C. Associativity of union. Now associativity of intersection. A intersection B intersection C is equal to A intersection B intersection C. Associative law. Now we'll see the next, that is distributive law. Distributive law, it means intersection distribute over union and union distributes over intersection from left and right also. So first law, first distributive law, A intersection B union C is same as A intersection B union A intersection C. Right? Second law, A union B intersection C is equal to, you can write here A union B intersection A union C. Right? This is your distributive law. Union is intersection is distributive over union and union is distributive over intersection. Now De Morgan's law. So De Morgan's law, here we will get again two more laws from left and from right also. Exactly similar way you can write. Now De Morgan's law. De Morgan's law, it means what? First, A union B complement is equal to A complement intersection B complement. Second, A A intersection B complement is equal to A complement union B complement. Right? This is your De Morgan's law. Now absorption law. First absorption law is here A union, here A union A intersection B is equal to A. And second, A intersection A union B is equal to A. Right? And double complement, it means complement of complement is equal to the same set. Right? So double complement, it means A complement complement is equal to A. This is your algebra of sets of operations. Now cardinality of sets. What do you mean by cardinality of sets? So here cardinality of sets, it means the number of elements which are present in a set is called cardinality of a set. Okay, so number of elements of a set, number of elements present in a set is called cardinality of set. Number of elements present in sets is called cardinality of a set. Okay. For example, suppose A is equal to here A is equal to 1, 2, 3, 4. So what is the cardinality of A? So cardinality of A is denoted by this. So cardinality of A is equal to 4. Number of elements present in that set is a cardinality of sets. Okay. Now next is partition of a set. You mean by partition of a set. Okay. Let A be the set. Let A be the set. A be the set. And A1, A2 up to N are subsets of A. A1, A2 up to N are subsets of A, then A1, A2 up to N are called partition of A, are called partition of A if first one A1 union A2 union AN is equal to A, that is second, that is union of AI is equal to A. Union of AI is equal to A. And second condition here, second condition, union of AI intersection here, AI intersection AZ is equal to phi if I is not equal to Z. AI intersection AZ is equal to phi if I is not equal to Z. Okay, so this is your partition of a set. So in short, we can represent diagrammatically partition of a set by here present partition of a set. Diagrammatically, in short, you will get clear cut idea of a partition. Now, suppose this is your set A. Right? Suppose this is your set A, right? And we will partition into, suppose this is A1, this is A2, this is A3, this is A4, and so on up to N. Okay? Up to N. So union of all these sets, union of all these sets, it will gives you A, right? So union of I varying from 1 to N is equal to A, and intersection of AI intersection AJ AI intersection AJ is equal to phi. There is no any common elements between this. It means pairwise intersection is empty. It means A1 intersection A2 empty, A1 intersection A3 empty, A2 A1 intersection A4 empty, A3 intersection A2 empty, and so on. It means pairwise disjoint. Okay, these two sets are pairwise disjoint. So A minus B, B minus, and so on. A intersection B are pairwise disjoint sets. Okay. So this is your partition of a set A. You can take any set. Suppose A is equal to. So I will tell you how to partition the given set A. Suppose A is equal to 1 to 10. So partition of A we can write here. Suppose here contains only one element. This set contains 2, 3, 4. Right? This set contains 5, 6. This set contains 7, 8, and this set contains 9, 10. So this is partition of a set A. So A1, A2, A3, A4. So partition of this set is A1, A2, A3, A4. So you will get partition of this set is A and pairwise disjoint. A1 intersection A2, A1 intersection A3, A1 intersection A4. So partition P can be written as in the form of here. Partition P is equal to, you can write here 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10. Right? So this is the partition of a set. Now next, we'll see principle of inclusion and exclusion for two sets. So cardinality of A union B, cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. Okay. Now here cardinality of A intersection B intersection A, cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. Principle of inclusion and exclusion, it means this includes and excludes also. It means separated. If you want to calculate the number of elements present in the union of a set, then how we will calculate? So we will take the separately the number of elements present in A as well as the number of elements present in B, and we subtract the number of elements which are present in both the set. Otherwise that elements will be counted twice. So that's why we are subtracting from this. So here principle of inclusion and exclusion of two sets. Why it is said to be inclusion and exclusion? This includes and this excludes. That the common elements are excludes, and here number of elements. It means the total number of elements we want to calculate in the set, a union of this set. So we can write it here, union of cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. Right? Now here principle of inclusion and exclusion for three sets A, B and C. Hence cardinality of A union B, union C is equal to, we will take the cardinality of separately. Now if you observe here plus alternate, negative and positive sign will be get. So cardinality of A plus cardinality of B plus cardinality of C minus cardinality of B intersection C minus cardinality of A intersection B minus cardinality of, here we require here minus, otherwise it will be plus only if you take in the bracket, right? Here minus cardinality of A intersection B minus cardinality of A intersection C, right? And plus cardinality of A intersection B intersection C. Now this is the cardinality of, here you will get the union of any three sets. So cardinality of A union B union C, we can write here cardinality of A plus cardinality of B minus plus cardinality of C minus cardinality of A intersection B minus A intersection C, and plus minus, here one more thing is remaining, minus cardinality of B intersection C and plus cardinality of A intersection B intersection C. Okay, so this is your final rule of cardinality or principle of exclusion and inclusion and exclusion for three sets A, B and C. Similarly, we can write down the inclusion and exclusion principle for n set, finite collections of sets. So if you observe here, we can take the individual cardinality of individual sets. It means summation I varying from 1 to n ai minus summation I varying from 1 less than or equal to I less than or equal to z less than or equal to n ai intersection aj plus summation n varying from 1 to infinity 1 ij k. It means I, j and k varying from 1 to n, and here ai intersection aj intersection ak plus and so on minus 1 raised to n minus 1 cardinality of a1 intersection a2 intersection a3 intersection and so on up to an. So this will give us the cardinality of the sets n. Now, so by using this cardinality of sets concept, we will solve some examples how to find out the number of elements present in the given set with the given condition. Okay. Now see, consider a set of integers from 1 to 250. Here. Okay. Consider the set of integers from 1 to 250. Find how many of these numbers are divisible by 3 are divisible by 3 or 5 or 7. Also indicate how many are divisible by 3 or 5 but not by 7. So if we go by manually here, if we go for counting the number of integers from 1 to 50 which are divisible by 3, 5 or 7, it will take a time consuming process, right? It will be a time consuming process. So instead of finding by using that method, we will use the principle of inclusion and exclusion. So within that minutes, you will get the number of elements present in the given set with the given condition that the number of integers from 1 to 250 which are divisible by either 3 or 5 or 7. Okay, so we will separately, we denote, let a b c denotes, we will denote first set, let a b c denote the set, denote the set of integer, denote the set of integers from 1 to 250, from 1 to 250 divisible by 3 or 5 or 7. Okay, so here 3 or 5 or 7. So we will calculate the number of integers which are divisible by, so a denotes 3, the number of integers set contains, let a denotes the set, the number of integers between 1 to 50 which are divisible by 3. So we will find out the number of integers which are divisible by 3, that is cardinality of a is equal to the integral part of here 250 by 3. We will take the integral part of this only. So 250 by 3, it means 3 is a 24, 3 3 is a 9. So integral part is this only. 83 is the integral part. Right. Now the number of integers, cardinality of b, it means it is equal to the number of integers which are divisible by 5. Right. So we can write here 250 by 5. So which is equal to 250 by 5, it means 50. Integral part is 50. Right. Cardinality of c, the number of integers which are divisible by 7. So cardinality of 250 by 7 is equal to here 35, right? So cardinality of C is equal to 35. Now we will calculate the cardinality of A intersection B, right? It means the number of integers which are divisible by both 3 and 5, right? So it will gives you 250 by 15 is equal to, here integral part is 16. Now we will calculate the number of integers which are divisible by 3 and 7. So 3 into 7. Integral part of this 250 by 21, which is equal to integral part of this is 11. No. cardinality of B intersection C is equal to the number of integers which are divisible by 5 and 7. So we'll take the integral part of this. So 250 by 5 into 7. So that is 250 by 35. So you will get here 7. Okay. So the integral part of this is 250 by 35 is equal to 7. Now integral part of A intersection B intersection C. The number of integers which are divisible by 3 and 5 and 7. Okay. So here you will get 250 by 105. So that is, here you will get I think 2, right? These are, so here you will get integral part is 2. 250 divided by 105. It means it is 2. Okay, so cardinality of A intersection B intersection C is equal to 2. Now first we will find out. Now we know all the cardinalities, but we don't know the number of integers either divisible by 3 or by 5 or by 7. It means we have to find out the cardinality of A union B union C. It means the number of integers between 1 to 250 which are divisible by 3 or 5 or 7. By principle of inclusion and exclusion, we can find out here cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B minus cardinality of A intersection C minus cardinality of B intersection C plus cardinality of A intersection B intersection C. Right? Now we know all the values. Cardinality of A is 83 plus 50 plus 35 minus, here we can take inside intersection B is 16 plus 11 plus 7 and plus 2. Okay, so this will gives you 5 plus 8, 5 plus 3, 8, 8 plus 8, 16, 168 minus, how much it is? 16 plus 7, 7 plus 1, 8, 8 plus 6, 40, carry 1, 1 plus 1, 2, 1, 3. There is 34 plus 2. So here 160 plus 2, it means 170 minus 34. So you will get 10 minus 4, 6, 6 minus 3, 6. So it is 136. So total number of integers which are divisible by either 3 or 5 or 7 are 136. So what is the next question? The next question is also indicate how many are divisible by 3 or 5 but not by 7. Find out the number of integers which are divisible by either 3 or 5 but not by 7. So how we denote it by? Denoted by the number of integers which are divisible by 3 or 5 but not by 7. It means we will calculate the number of integers which are, we know that the number of integers which are divisible by either 3 or 5 or 7 are 136. So we can exclude the number of integers A union B union C minus, if we exclude the number of integers which are divisible by 7 is equal to, we will get here 136 minus the number of integers which are divisible by 7 are, here we are getting only divisible by 7 are 35. So you will get the final answer here 136 minus 35, that is, here you will get 101, right? 101 integers which are divisible by 3 or 5 but not by 7. Okay, what we have done? The total number of integers which are divisible by either 3 or 5 or 7, we have taken it, and we subtracted the number of integers which are divisible by 7 That will gives you the number of integers which are not divisible by 7. Clear? So both the conditions are clear. Now, next we'll see the next question here. So among 100 students, 32 study mathematics, 20 study physics, 45 study biology, 15 study mathematics and biology, 7 study mathematics and physics, 10 study physics and biology, and 30 do not study any one of the three subjects. Okay, as 30 do not study any one of the three subjects, it means how many total number of students are studying only? Only 70 students are studying, right? So here we can write the cardinality of x. It means total set. Cardinality of x is equal to 100, right? And the number of integers, number of students who study only mathematics. So we denote the set A by who study mathematics. Let A, B, C, we will write here. Let A, B, C, let A, B, C denote the set of students, denotes the set of students studying mathematics, physics and biology respectively, right? It means A denotes the number of students who study mathematics, B denotes the number of students who study physics, C denotes the number of students who study biology. Okay, now we will write one by one. So cardinality of x, it means total number of students are 100. Now A denotes the number of students who study mathematics. So how many students study mathematics? 32 students study mathematics, right? 20 students. B denotes the number of students who study physics. So 20 students study physics. 45 students study biology, right? And 15 study mathematics and biology. It means cardinality of A intersection B is equal to biology, it means C, right? So cardinality of A intersection C, it means 50, right? 7 study mathematics and physics. It means cardinality of A intersection B, right? Cardinality of A intersection B is equal to 7. Now, cardinality of B intersection C. 10 study physics and bio, right? Physics and bio. So 10 students physics and bio. And the number of students who do not study any one of that subject, that is cardinality of A intersection B intersection C dash, A dash intersection B dash intersection C dash is equal to 30, right? So cardinality of A dash intersection B dash intersection C dash is equal to 30. So that is, you will get the cardinality of A dash intersection B dash intersection C dash is nothing but your cardinality of X minus cardinality of A union B union C, right? So here cardinality of X is 100 and here is cardinality of A dash intersection B dash is 30. So here cardinality of A union B union C, it means either one of the subject can be studied. Here A union B union C is equal to here 100 minus 30, so you will get 70. So there are 70 students who study either maths, either physics or bio. Okay. Now, we have to calculate the number of students who study exactly one subject, right? Who study exactly, find the number of students studying all the three subjects and find the number of students studying exactly one of the three subjects, right? So we will calculate first the number of students study all the three subjects. It means we have to calculate A intersection B intersection C. So for that we will first A intersection A union B union C, cardinality of A union B union C by principle of inclusion and exclusion, cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B minus cardinality of A intersection C minus cardinality of B intersection C plus cardinality of A intersection B intersection C. So here cardinality of A union B union C, that we that we have 70. It means either one of the subject can be studied, 70 students, and cardinality of A is 32 plus cardinality of B, as we already calculated here. Cardinality of B is 20, cardinality of C is 45 minus cardinality of A intersection B. So minus, I am keeping minus sign outside. A intersection B is 7, yes, plus cardinality of A intersection C 15 plus cardinality of B intersection C 10 and plus cardinality of that we have to find out exactly one subject how many students are studying. So 70 is equal to here 32 plus 20, that is 52 plus 45, so 97 minus here 15 plus 10, 25 plus 7, 32, right? And plus cardinality of A intersection B intersection C. So here you will get 97 plus 32, 97 minus 32, so 5, 9 minus 3, 6. So 70 minus 65, 70 minus 65 is equal to cardinality of A intersection B intersection C. So the number of students who study exactly one subject is equal to cardinality of A intersection B intersection C is equal to 5. It means there are 5 students who study exactly all the 3 subjects, right? Now, we will find out the number of students who study exactly one subject. It means only mathematics, only physics and only biology. So, the number of students studying exactly one subject, the number of students studying, only mathematics is cardinality of A minus cardinality of A intersection B minus cardinality of A intersection C and plus cardinality of A intersection B intersection C. Now see, the total number of students who study mathematics, we will subtracted the number of students who study maths as well as bio, maths as well as physics, right? And we are adding study all the 3 subjects because it is counted only once. So number of cardinality of A is 32 minus 7 minus 15 plus 5. The total number of students who study here 32 minus 22 minus 22 and 32, so 10 plus 5 15. So there are 15 students who study exactly mathematics, right? So number of students who study only, we can calculate the number of students who study only physics is number of students who study only physics is cardinality of B minus cardinality of B intersection A minus cardinality of B intersection C plus cardinality of A intersection B intersection C, right? So cardinality of B is given 20 minus 7 minus 10 plus 5 is equal to 8. There are 8 students who study exactly physics, right? So what? Yeah. Now we will find out the number of students who study exactly biology, right? Only biology. Number of students studying, number of students studying exactly biology only. Okay, then so cardinality of C minus cardinality of A intersection C minus cardinality of B intersection C plus cardinality of A intersection B intersection C is equal to here 45 minus the total number of students who study only biology are 40 total biology students are 45 minus biology as well as here physics. So 15 minus 10 plus 5. So you will get 25. Therefore, number of students studying exactly one subject, studying exactly one subject is 15 plus 8 plus 25. There are 48 students. Okay. So we can calculate here with the help of Venn diagram also. Calculate the number of students study exactly one subject is A, B, A and C. How many students study exactly all the three subjects? There are 5 students who study all the 5 subjects, all the 3 subjects, right? And number of students who study maths and bio. So how many students? A intersection B is 7. So there are 7 students who study exactly maths and A denotes physics. Okay. Studies student maths and physics, right? A intersection B. And the number of students who study maths, B denotes the physics and C denotes bio. We'll write down here biology, physics. The same example we can solve with the help of Venn diagram also, and here is maths. Okay. Now A intersection maths and bio. So 5 are already counted. So here you will get 2, right? So total number of students who study maths and bio is 7. Now the number of students who study maths and bio, sorry here, maths and bio is 15, right? A intersection C is equal to 15. So 5 already counted. So how many students are remaining here? 10. Now, the number of students who study physics and bio are 10. 5 already counted. So here are 5. Right? Now, exactly the number of students, total number of students who study maths are 32. So 10 plus 5, 15 plus 2, 17. So here 13, 50, 32 minus 17. So you get here 15. Right? Now, here the number of students who study physics. Physics are 20. So 5 plus 5, 10 plus 2 already counted. So 12. And 20 minus 12, so 8. Here the number of students who study biology are given 45. So already 20 are counted. So 25. Now with the help of this diagram, you can find out any number of question. You can solve any questions regarding with this. So how many students study exactly all how many students study all the 3 subjects? 5. The number of students studying exactly one subject, that is maths, physics and bio, are 15 plus 8 plus 25, right? So that is 48. Now, if the question also asks how many students study exactly 2 subjects, That also you can answer here 10 plus 2 plus 5, right? So it is easy to answer with the help of Venn diagram. So there are 17 students who study exactly two subjects. There are 48 students who study exactly three subjects. Exactly one subject. And there are 5 students who study all the 3 subjects. Clear? I hope you are getting it clear. So with the help of Venn diagram. Okay, now we'll move forward for the next question. Now see, in a survey of 60 people, it was found that in a survey of 60 people, it was found that 25 read Newsweek magazine, 26 read Time, 26 read Fortune, then also 9 read both Newsweek and Fortune, 11 read both Newsweek and Time, 8 read both Time and Fortune, and 8 read no magazine at all, right? So 8 read no magazine at all. So we will find out the number of people, find out the number of people who read all the 3 magazines, just like we have seen how to show by using Venn diagram. So with the help of Venn diagram also we can solve easily here. And or we will also solve by using principle of inclusion and exclusion. If the question asks for the 4 to 5 marks, then you have to solve with the help of inclusion and exclusion. And if you are solving for the MCQs, then you can solve with the help of Venn diagram also. Now fill the correct numbers in all the regions of the Venn diagram. See, here we have to find out Venn diagram also. Determine the number of people who reads exactly one magazine. Okay. Now let's start. First we will denote the number of, okay, here. Let n denote the number of people who read Newsweek. Let n denote number of people who read Newsweek, right? Who read Newsweek. So total number of, so cardinality of n is equal to 25. There are 25 people who read Newsweek. Now let T denote number of people who read Time, Time magazine. Okay. So cardinality of T is equal to 26. Right? Now the next is F denote the number of people. F denote the number of people who read Fortune magazine. Who read Fortune magazine. Right? So cardinality of F is equal to 26. Right? And the total number of people are 60. So cardinality of X is equal to 60. Okay. Now here we will write down, so cardinality of N intersection T is equal to 11, news as well as time. Then cardinality of T intersection F is equal to 8, right? Cardinality of N intersection F is equal to 9. Cardinality, who read none of the magazine, T dash intersection F dash is equal to 8, right? By De Morgan's laws, you will get N intersection T intersection F is equal to cardinality of X minus N union T union F, right? So here is 8, here is 60 minus N union T union F. So which gives you cardinality of N union T union F is equal to 52. So there are 52 people who read at least one of the magazine. Okay. Now, what is our first question? Here we have to find out who read all the three magazines, right? So who read all the three magazines? So that is cardinality of N union T union F is equal to cardinality of N plus cardinality of T plus cardinality of F minus cardinality of N intersection T minus cardinality of N intersection F minus cardinality of T intersection F plus cardinality of N intersection F intersection T, or cardinality intersection F, right? So you can write here number of people. We know that cardinality of N union T union F is 52 is equal to cardinality of N is 25 plus 26 plus 26 minus N intersection T is 11. So I am taking outside here 11 minus n common plus cardinality of N intersection F is 9 plus cardinality of T intersection F is 8 plus cardinality of N that we have to find out. N intersection T intersection F is equal to, so here 50 cardinality of, we can directly write down N intersection T intersection F is equal to here 52 minus, you will get 25 plus 26 plus 26 52. So 52 52 get cancel out here. So we get 25 minus here 20 plus 8. So minus 28 plus, so minus 3, it means 3. So N intersection T intersection F is equal to 3. So cardinality of N intersection T intersection F is equal to 3. It means there are 3 people who reads all the 3 magazines. Okay. So there are 3 people who reads all the 3 magazines. So second, what is our second question? Fill the correct number in all the regions and determine the number of people who reads exactly one magazine. So first we will denote with the help of Venn diagram. Okay. So here this is N, Newsweek, Time and Fortune. So there are 3 people who read all the 3 magazines. Now how many magazines who read N intersection T? There are total how many people? N intersection T 11. But out of that 3 are already counted. So 11 minus 3, that is 8. Right? Now how many people read both T and F? It means Time and Fortune. 8. So out of that 3 are already calculated. So 8 minus 3, that is 5. Now N and F, there are 9 people. So out of that 6 are already counted. So here is 6. Okay. Now count. There are total number of people who read on Newsweek are 25. So out of that 8 plus 6, 14 plus 3, 17. 17 are already counted. So 25 minus 17, 8. Here total number of people who read Times. So there are cardinality of T is equal to 26. So 26, so out of that here 16 are already counted. So there are 10 people who read only Times. And here T intersection, here is F. So 6 plus 3, 9 plus 5, 14. 14 plus here total number of people are, fortunate is 26. 26 out of 26, here are 8, 9 plus 5, 14 already calculated, so remaining 12. So how many people who read exactly one magazine? So 8 plus 10 plus 12. So there are 8 plus 12 plus 10, it means 30 people who reads exactly one magazine. Reads exactly one magazine. Okay. Now next is Now see, in a class of 55 students, the number of students studying different subjects are given below. Maths 23, here physics 24, chemistry 19, Maths plus Physics 12, Maths plus Chemistry 9, Physics plus Chemistry 7, and all the three subjects are 4. Find the number of students who have taken first one at least one of the subject, second one exactly one subject, third one exactly two subjects. Okay, so that also we will calculate by using Venn diagram also, and with the help of uh, principle of inclusion and exclusion also. Okay, so we will calculate first. Let M denote the set of students studying mathematics. Okay, we denote here. Let X denote the universal set X. X denote universal set X. Right? Now here, let M denote the set of, let M denote the number of students studying. M denote the number of students studying mathematics. Next, and P denote the number of students. P denote the number of students studying physics, and C denotes number of students studying chemistry. Right? So cardinality of X, total number of students are 55. Right? Cardinality of M, number of students studying mathematics are 23. Now, so cardinality of P, number of students studying physics 24. Number of cardinality of C, number of students studying chemistry 19. Number of students studying maths and physics 12. Number of students studying maths and chemistry 9. Number of students studying physics and chemistry 7. And number of students studying maths, physics and chemistry are 7. Okay, so we will calculate here the number of students studying all the three subjects, right? M union, P union, C. Okay, so here we know that cardinality of M union P union C is equal to cardinality of M plus cardinality of P plus cardinality of C minus cardinality of M intersection P plus cardinality of M intersection C plus cardinality of P intersection C, right? Plus cardinality of M intersection P intersection C. So here cardinality of M union P union C is equal to, here cardinality of M is 23 plus 24 plus 19 minus 12 plus 9 plus 7 plus 4. So the number of students who studying either maths or physics or chemistry is 42. You can calculate this. So you will get either maths or physics or chemistry is 42. Okay. So we have to find out first one, at least one subject. It means there are 42 students who study at least one subject. Now second question is that, second question, exactly one subject. Okay, it means we have to calculate separately only maths, the number of students who study only maths, only physics and only chemistry. So that will gives you the number of students exactly one subject. So number of students, as we have already calculated here, number of students studying mathematics but not physics, not chemistry, right? Studying mathematics, exactly one subject. Mathematics but not physics, not chemistry, which is equal to cardinality of M minus cardinality of M intersection P plus cardinality of M intersection C, right? And plus cardinality of M intersection P intersection C. We get here cardinality of M, that is 23, minus cardinality of M intersection P plus 9 plus 4 is equal to 6, right? So there are 6 students who study exactly mathematics, not physics, not chemistry. In the similar way, we can calculate number of students studying on physics but not maths, not mathematics, not chemistry, right? So you will get cardinality of P minus cardinality of P intersection M plus P intersection P plus cardinality of P intersection M intersection C. Cardinality of P is 24 minus, here is 12 plus 7 plus 4. We get here 24, 19 plus 4, 24 minus 19 plus 4, that is 9, right? In the similar way, we will calculate the number of students studying chemistry. Number of students studying chemistry but not physics, not maths. But not physics, not maths. Get cardinality of P minus cardinality of M intersection C plus cardinality of P intersection C plus cardinality of M intersection P intersection C, right? So cardinality of C is 19 minus, here 9 plus 7 plus 4, which is equal to 7. So there are exactly 7 students who study only chemistry, not physics, not math. Okay, so we can calculate the remaining part with the help of third part we have to calculate. So there are total number of students who study exactly one subject is here 7 plus 9 plus 6, right? 7 plus 9 plus 6, it means there are 22 students who study exactly one subject. Okay, so the who study exactly one subject, number of students who study exactly one subject is, here you will get 9 plus 7 plus 6 plus 9 7 is equal to 20. There are 22 students who study exactly one subject. Now we have to find out number of students who study exactly two subjects. So once we are getting this, we will find out with the help of Venn diagram. Here we will one more slide. this we'll see with the help of Venn diagram the number of students who study exactly two subjects, right? Here is maths, physics, and chemistry, right? Now there are how many students who study exactly one subject? Exactly all the three subjects. So M intersection P intersection C, 4. M intersection P intersection C is equal to 4. Okay? There are 4 students who study exactly all the three subjects. Okay, now we have calculated already maths and physics study the total number of students who study maths and only maths, who study only maths are 6, right? Who study only physics are 9, who study only chemistry are 7, right? Now total number of students who study now here maths and physics, so there are total number of students are maths and physics are here 12. So out of that 4 are already counted. So here are 8. Right? The number of students who study maths and chemistry. Uh, Maths and chemistry are 9. So out of that 4 are already counted. So here are 5. Out of that here total number of students who study maths and physics and chemistry are given. Physics and chemistry and C are given 7. Right? Out of that 4 are already counted. So here are 3. So how many students who study exactly two subjects? So exactly two subjects is maths, physics, maths, chemistry, math, physics, chemistry. So the number of students who study exactly two subjects, number of students studying exactly two subjects, exactly two subjects are 8 plus 5 plus 3, right? These students studying both subjects, maths, chemistry, maths, physics, physics and chemistry, right? This. These students study exactly two subjects. These students study exactly one subject. So 8 plus 5, 13 plus 3. There are 16 students who study exactly two subjects. It's easy to find out with the help of Venn diagram. I hope you are clear how to find out the number of students or whatever condition is given, that at least one, at least exactly once, only one, okay, or all the three. So that part we will calculate by using inclusion and exclusion principle, which is very simple way we can calculate by using principle of inclusion and exclusion, so that it is very easy to clear, or which is easy to find out the number of students with the given condition. Okay. So I hope you are clear how to all the definitions of sets. I taken it from the basics, very basics. In the next lecture, we will study here logic here. So I cover up all the parts of set theory here, which is main. First is principle of inclusion and exclusion, cardinality of sets, and then laws, distributive algebra of sets operation, then here all the operations, that is union, intersection, difference, symmetric difference, disjoint sets, then intersection, union of sets, then operations on sets. These are the operations on sets. then power set of A, then methods to describe the sets and set, definition of a set, methods to describe the set, then proper subsets, empty sets, power set, every part I have cleared here. I hope you are getting it clearly. So please, if you are liking my videos, please do like, share and subscribe. Thank you so much. I will be here tomorrow in the same time from 11:15. So in that lecture we will cover up the logic. Okay, mathematical logic part we will cover up. In that we will cover truth tables and many basic, that is normal forms and everything we will cover up in the next lecture. Okay. Thank you so much. Keep watching and happy new year to all of you.